Okay, we'll be starting in a minute or two. While I'm just waiting for the go-ahead on the web stream, most of you are sat in the right-hand side of the room. If you want to space out more, there's lots of space on the right-hand side of the room if you're on the left-hand side. Okay, I'm just waiting for the okay that the webcast is live. Okay, we're good. Okay, welcome. I'm not sure which is harder to believe, that we've done nearly 50 of these, or that it is 2.5 years since we were last together in Manchester. I'm Keith Mitchell, UKNOF Forum Chair. Before we start today, I just want to run you through a few pieces of information. It's not the usual boring stuff for me. There are a whole bunch of things that have changed since the last time. We're still here to try and make the UK Internet work better. I think over the past couple of years, the UK Internet has functioned extremely well. So, I think everyone in this room should take some pride in that. And we're here to try and distribute clue about how to make the Internet work better and not distribute virus in the process. So, it's our first hybrid event. As I'm sure those of you who drive hybrid vehicles are aware, the diagram is simple, the operation, there's a lot more detail to worry about and consider. We're going back to our usual live webcast format, so most of the people who are joining us are not joining via Zoom for once, so that's great. We'll be using the Mattermost chat platform that we've been using for over a year now. If you didn't sign up for it, I recommend that you do so, even if you're in person and certainly if you're remote. There's a general channel which is bridged to IRC for general discussion. We will also be doing polls on that for speaker feedback. And there is a separate channel if you're not in the room and you're attending remotely and you want to ask speakers questions, then there is a separate channel which you need to sign up for so that you can post your questions there. And please only post questions on that channel and keep the general discussion towards the general chat channel. At the end of the presentation, the Mattermost poll will pop up, and that's your chance to give feedback on the speakers, which both the speakers and the program committee find very useful. We're on the usual social media channels. Hashtag is #UKNOF48. Hopefully you've all found the Wi-Fi. There is the SSID and PSK if you don't have them. Break, lunch and toilet locations, as usual. The break will be in the charter foyer behind us. The toilets are out the door there and to your left. In the event that there is a fire alarm, you will see emergency exits at the back and the right-hand side of the room. If you head out that way in the event of an alarm and go to the assembly point is the central foyer. On badges, if you need any help, you will see that there is a crew marker on the badges for anyone who's a UKNOF volunteer or committee member. If you need help, or go to the registration desk. We also have some first-timers. Welcome. I'm sure you will all make the first-timers welcome. Their badges are also appropriately marked. And again, if you're a first-timer and you're feeling a bit lost, you need some help, then go speak to the registration desk. So what's different? Well, it's been an interesting 21 months for all of us. We've kept the lights on at UKNOF through virtual events. They've not been so good at raising money for us. So I'm afraid there are some things at this meeting that are different because of the pandemic, and there are some things at this meeting that are different because we need to save costs and preserve our funds to keep the organisation going into next year. If you paid for a box lunch at registration, your name is on a list at the catering stand, so just ask the catering staff, and there are some options there in case you have any dietary requirements. So again, speak to the catering staff. I'm afraid there's a few things that we do usually do that we're not doing this time around. There's no iPad probe distribution, there's no PGP signing session, there is no creche. Hopefully we can get back to these as we proceed into next year. So, One thing that it's important to understand is how we're doing questions, because we're not passing microphones around like we used to in the physical events. We're not doing it via the Zoom Q&A window like we've been doing for the past year and a half. If you're a remote attendee, then the way that you ask questions is to go into the Mattermost UKNOF48 questions channel and then type your question, and then the Q&A monitor will read that question out for you. If you're in the room and you want to ask a question, we have a question microphone here, so please line up at that to the right, and the session chair will prompt you when to speak. And then a reminder, whoever you are, if you're asking questions, for the benefit of everybody on the webcast, please state your name and affiliation. And the questions will be time permitted, but there's 5 to 10 minutes at the end of each slot for that. Also, the other thing is there is some time lag on the webcast. I think it's maybe about 20 seconds or so between what's going on in the online world and what's happening in the physical room here. So if everyone can just be a little bit patient and bear with that. So, pandemic safety. We have a UKNOF respect policy, and in general, our audience and participants are extremely well behaved. Applies both offline and online. We can have respectful discussions about VI versus Emacs. I'm sure we can have respectful discussions about Pfizer versus Moderna, whatever. But just understand that not everybody's perspective and comfort level with where we are may be the same as yours, and please pay attention to the respect policy which you agreed to when you signed up to attend the meeting. Everyone in the building has been required to show proof of vaccination to get in. We've spaced the seating out, as you can see. The venue has made some upgrades to its airflow since the last time we were here. I mean, usually we would have 250 odd people in this room. We're maybe 100, which is a lot more than we're expecting. It's really good that you've all come here. But no mitigation is 100% effective. So we encourage you all to wear masks as much as possible. And the venue has also requested and recommended that at some point, either if you didn't do it this morning, at some point today or tomorrow, you take a lateral flow test just to make sure that you're pandemic safe. If you exhibit symptoms within a week of this event, please let us know and follow the appropriate public health guidelines for testing positive or showing symptoms that apply to where you live. We're not doing any badge or lanyard recycling. It's probably best if you just take your badges and lanyards away with you at the end of the meeting so that we don't finish up with a big heap of these to dispose of. So, we also know we've all been a bit starved of human contact over the past year and a half. So we've actually programmed longer breaks than we normally would so that you get a chance to catch up with everybody you haven't seen. But also just appreciate that everyone's comfort level is different. Again, please respect that. There are stickers available at registration to express your comfort level with whether you want to keep away from people or whether you're okay with fist bumps or whether you're actually okay with shaking hands. There's another chance to socialise at the end of today, pints and packets, between 5:30 and 7 o'clock. Again, in the gallery foyer, name badges required. So that is basically all the administrative stuff. I will now hand you over to the actual content. Marek Kozalski is our session chair for this afternoon, and Marek will be introducing the first speakers. Just before Marek takes over, I'd like to thank our sponsors. The sponsor for this event is LUNAP, once again, and a lot of individuals also, thank you, made a contribution towards the event. But also, what's even more important is our patrons who've supported us throughout the year, and that's Flex Optics, IPv4 at Market Group, Right NCC at premium level, and then at promoter level, we have ISC, Security, and also now Hilco have joined. And thanks to Bogons, our partner for the webcast, and Portfast for providing the upstream connectivity for this event. So I will now hand you over to Marek and our speakers.
Thank you, Keith. My name's Marek. I'm one of the programme committee here, and it is my great pleasure to introduce Andrzej Koletka from the RIPE NCC. who is going to be talking to us about a hands-on learning environment for virtual IPv6 security. Andre, are you able to hear me from the venue?
Yes, I hear you. I hope you hear me as well.
We can. And hopefully you can see the slides as well. If I could just remind you to say next slide, so we advance the slides.
Yes, I will. So I hope everything works. You can hear me.
Great. Over to you.
Perfect. So welcome. My name is Andre. I work for RightNCC, and in this talk, I would like to present you a environment that we use for our new training course on IPv6 security. Next slide, please. First of all, what is RightNCC Learning and Development? The departure I work for, it's a former training services. We used to provide, and we still provide trainings to our members of RightNCC. It started with face-to-face trainings about 20 years ago, but they are still like on, except for the pandemic situation, which made us suspend them temporarily. But we also do webinars. We did them even before it was full with pandemic. Where webinars are always live, delivered by people speaking like me, myself, or remotely, and have some interactivity with our participants. And what we also launched in 2014 was RightNCC Academy, which is basically an e-learning platform where people can learn some of our curriculum on their own pace, on their own computer, without any direct interactivity with trainers. And for this, the newest addition to our portfolio is actually a program called Certified Professionals, where if you get some knowledge, you can actually prove that you have that knowledge by getting certified, which means absolving an exam of about 50 questions in a controlled environment. We use something called remote proctoring, where you actually have to prove your ID in front of your web camera, and then you are observed by online proctor over webcam, so you cannot cheat, and it has to be you who is making the test. And therefore, the badge that you can earn, like the one on the slide, is actually like recognized that is really you who has the knowledge that we prove. Next slide, please. Yeah, and the newest part that we have in the RightNCC Academy is called IPv6 security. This is something that we have been doing for a while in a face-to-face training course. Then during COVID-19 pandemic, we actually adopted this face-to-face training course into 3 2-hour-long webinars. But also we worked even before pandemic on adapting it into the e-learning environment. So now it's also e-learning course where you can learn about various aspects of security and related questions with IPv6, and also how to attack some vulnerabilities that are in the protocol or in its implementation, or how to mitigate against it. And for this e-learning, there is this new thing, which is the lab. We used to have similar lab for face-to-face training. Actually, we still do have it, but we don't do face-to-face trainings. Where you basically have 3 Linux machines, and it's like one machine belongs to Alice, the other to Bob, and the third to Mallory, who is trying to somehow intercept the communication between them. So basically, that's the idea behind this. So there are 3 machines connected to the same network. They can try various local network attacks, and also other things. And basically, there's like that thing. Next slide, please. The idea was how to deliver this environment for the e-learning, because for the face-to-face training, we actually are running these virtual machines in our own on-premise hardware. But for e-learning, this is a little bit hard, because the e-learning is free for everybody. So there can be like spikes of many concurrent users, and also users can take their own time and finish the lab in an hour or two, but maybe some longer time. So we are trying to find some solution that would be, let's say, very scalable and at the same time would not cost too much money, and should not put any limitation on how long are you allowed to play with it, because I think it's pretty cool to play even a bit more than what is allowed in the environment. So we decided that we will use, instead of cloud, we will use every other people's computers, and we will just deliver virtual machine image that everybody be able to install on their own computer and then play it completely locally on their own computer. Next slide, please. There are some challenges with that, of course, because we have some portion of Windows users, some portion of Linux users, some portion of Mac OS users, and even though each platform now supports virtualization pretty well, there is no like common standard except for VirtualBox. But the VirtualBox is a little bit like, say, the lowest common base. Um, and also, if you run a virtual machine, you know that there's always like issues with screen resolution and with keyboard layout and things like that. So the idea how to solve it here was to run the virtual machine headless, so no deal with console, and deliver everything over web interface to the browser in the host machine. Yeah. And to make the virtual machine deliver even easier, we actually used a tool called Vagrant. Next slide, please. So, in the end, how does the product look like? Basically, what you have to do, and we have a special tutorial for that, which is like very straightforward. You have to install VirtualBox and install Vagrant on your computer, and once you do it, you just open terminal and type 2 commands, and after a few minutes, you will get a running environment in a virtual machine that is accessible on your local host address, and then you will see three consoles of three and everything is deployed using Ansible, and everything is developed publicly. So there's a repository on GitHub of RipenCC where you can actually see the whole code that is building this lab environment from scratch, and you can also of course submit issues and even pull requests if you find some way to improve this environment. Next slide, please. Yes, so that's basically where we are now. I would like to invite you to give it a try. Give it a try to our new IPv6 security e-learning course and also the labs. But of course, so far we are collecting feedback from users to see whether they are satisfied or what are the issues with running labs like this, because it's still like more or less experiment to see whether this is actually a viable way to go forward. So far, in my opinion, is that yes, it seems that it is a way forward. But of course, the next labs and next e-learnings will probably need also some let's say, more real networking gear than just Linux servers. So I'm now investigating a way how to plug in some routers. Like now there are some routers available as containers, so this should be like pretty straightforward. But of course, the other thing is if we want to have it distributable like this, then the license agreements can be against us, because if something is just free for use, it doesn't necessarily mean that it's also free to redistribute. Next slide, please. Yeah, and that's everything from me, and I'm ready to take some questions if there are.
Thank you, Andre. If there are any questions from the room, please come to the front and line up and state your affiliation and name. Otherwise, if you're on the webcast, if you're watching the webcast, please type in the questions channel and Ben will relay your question to the floor. Do we have any questions for Andre from in the room? And we'll just leave it a little longer for the lag of the webcast. Doesn't seem like there are any questions. So I think I will say thank you very much, Andre. I found the talk very interesting. And thank you for presenting about the security lab.
Thank you very much, and have a nice rest of the UKNOF.
Thank you. We're going to be keeping the IPv6 theme going now, rather than recycling random old /8s. Sander Stefan is coming to talk to us about CPE and give us an update about the RIPE 554 policy with this talk about RIPE 554 biz. Sander.
So, hello everybody. My name is Sander Stefan, but I'm not here just on behalf of myself, but also on behalf of the whole team. So, these are the people who have worked on this series of RIPE documents. So, what are we talking about? What is this document? So, it's a guidance document for what to ask for if you're buying IPv6 capable equipment. Because, especially when this was written, but it still happens, you ask a vendor like, oh, does it support IPv6? And they're like, yes, it supports IPv6. See, there's one checkbox here that mentions IPv6, so it's mentioned somewhere, so it supports it. But it doesn't say anything about whether it's actually usable. So this is a document that helps you when you're, especially for enterprise, for big organizations, when you are procuring equipment. So this is what you would put in your tender, and it's meant as a template. So take the document, see what applies to you, what doesn't apply to you, and then use that as the basis for your purchase orders. However, what we also see is basically nobody actually does that, and most people just say, oh, equipment has to comply with RIPE 554. So that works as well. This document is written by the RIPE IPv6 working group. So even though we are the authors and we started it, this is not our document. We are just the shepherds of it. And actually the decisions on what goes in and what doesn't and what changes to make are all made in the RIPE IPv6 working group. It was quite successful. We actually had governments translate it into the local language and just include it in the purchasing manuals for the government themselves. We had companies that rely on this. We even had one vendor, I won't name them, but at some point we were talking to them and we're like, so, you know, what's your roadmap for IPv6? What are you planning to do? And they looked at us like, why are you asking us? You wrote the thing. Because what was in RIPE 554 was what big enterprises were demanding, so that was their development roadmap. So a document like this actually has quite some power. So how did this all start? Well, in Slovenia, a good friend of mine, Jan George, was pushing the government to require IPv6 when buying new services and equipment. So they're like, yeah, but what does that mean, require IPv6? What should we actually ask for? And at that point, you know, like, yeah, what do you ask for? Like, there's a whole list of RFCs, and since, you know, this is the internet, the list of RFCs is basically the list of requirements. So Jan made a list in Slovenian about what the government should ask for from their vendors. So we were sitting in a RIPE meeting, and Jan was sitting next to me. We're just chatting, and he's like, "Hey, by the way, I got this list. Do you think this would be useful for more people?" And I looked at it and was like, "This is brilliant. We need this." But yeah, the document wasn't Slovenian, so we put it in Google Translate, and then actually translated it after that. So we took the Slovenian document, we translated it into English, cleaned it up a little bit, and that's what became RIPE 501, the original version of this document. So posted to the mailing list, hey, we have a good idea, look at this document, is this useful? And then 2 months later, we had a RIPE policy, or policy RIPE document. It's not a policy document. So, you know, easy. But then the questions came in, like, why did you choose this? Why didn't you choose that? What about this? What about that? So, because, yeah, for 501, we could just say, like, oh, it's just a translation of the Slovenian version. We're not actually touching the content. It's just informational. But then, you know, it became a community thing, and we actually started interacting with the community to try to make it something that was that had a very broad consensus and actually had been discussed. Yeah, like I said, I skipped this bit. So yeah, it might be superseded by a new version, and that's exactly what happened. So beginning of 2011, we started working on the successor to RIPE 501. So, like I said, it was a translation of the Slovenian document. We started actually discussing it. This is a list of the, this is copy-pasted from the RIPE document of all the contributors who actually helped improve it. So as you can see, that's quite a list. So we started in January. January 2011 we started. In June 2012, the revised document was finally ready. So we basically spent a year and a half processing all the updates. We completely changed the document, made several sections like focused on, okay, what should a host do? What should a switch do? What should a router do? Even switches are like, do we need enterprise grade or just, you know, consumer grade? So after this, we were really happy with the new document, RIPE 554. But yeah, at that point, we were also a bit tired of it. We spent a long time working on it. It was very hard to get consensus. So, yeah. Oh yeah, this is the main...
Good afternoon, everyone.
Hello. Good afternoon to you too. So yeah, like I said, we had lots of sections, consumer grade, enterprise grade, routers, security equipment, CPEs, everything. We made it became a very extensive document. And then, like I said, we were discussing, okay, but at some point we should update it again. Because RFCs get updated, or there are new RFCs that might be relevant. But yeah, 554 was like the famous number now, so we didn't really want to replace it with a document with a new number. And it was a lot of work, so we were quite hesitant to start working on a new version. And that's why it's taken so long. So finally, this year, we decided to do it. Like, okay, this document is now almost a decade old. It's time to update it. So we gathered the courage, and then we're like, hey, what are we going to do? Are we going to expand the categories, go into more detail? I know actually in Germany they used RIPE 554, but they were like, oh, it's not accurate enough. So instead of just listing the RFCs, they actually listed the RFCs with each may and should specified whether they required this bit or not. So, you know, you can go into a lot of detail with this. In the end, we, basically for our own sanity, we chose to just keep it simple. Do basic updates, bring it to the current level of RFCs, like replace the old numbers, add the things that have been, the sensible things that have been developed, but not change too much, because otherwise we were afraid that it's going to take another year and a half before we have a new version. So that's where we are now. Of course, the basic things. You proofread a document a dozen times, and 5 seconds after you publish it, you spot a big error. That's just how it works. So we fixed those, we changed the references, we added fundamental RFCs like IPv6 over Ethernet. Like, it's basically a no-brainer that it should be there, but it wasn't actually mentioned anywhere. So we just added that. Things like send, secure neighbor discovery. There were some implementations, but it wasn't used anywhere. I think Cisco's could actually do it, but like Windows and Linux couldn't actually work with it, so it was pretty pointless. So we removed those. We had some references to the Bound v6 project. That doesn't exist anymore, so we cleaned that up. And in the next slides, I'll take you through the highlights of the things that we did change. So some things got, especially security related, have been tuned the last couple of years. For example, there's an RFC about how to handle overlapping fragments consistently. There's a RFC that specifies that atomic fragments, so IPv6 packets that have a fragmentation header but actually don't have multiple fragments, which is not very sensible, are now considered harmful. But yeah, when we wrote the original, the RIPE 554, atomic fragments were actually mandatory for some protocols. So, you know, things have, new insights have developed over the decade, so we adapted to that. Also, back in those days, IPv6 addresses were just generated from the MAC address of your Ethernet interface. By now, people realized that this might not be a good idea, so we added the RFCs that actually specify the privacy interface IDs. Of course, the privacy interface IDs changed too much and became unpredictable, so now there's a standard for stable privacy IDs. We made things like DNS options in the router advertisement mandatory, and we made mobile IPv6 optional. Mobile IPv6 also isn't used very much these days, so we just didn't feel it belonged in the mandatory category anymore. The consumer switches, basically nothing changed. Those don't have any fancy features, so but for the enterprise switches, a lot of enterprises desperately want DHCP-v6. Won't go into the details whether that's a good idea or a bad idea, but I've done consultancy for banks, and they're like, yes, we know we can do without it, but we have these very strict policies, and we just want to have this fine-grained control over our network. So we want we want DHCP-v6. Okay, so we actually looked at that, and in many places, like if you look, for example, at Android, Android religiously refuses to implement DHCP-v6. So we didn't want to make it mandatory for everything, but in an enterprise environment, you at least want to have the options to manage DHCP traffic. Even if you're not using it, you still want the option to block it, so nobody else starts talking DHCP-v6 on your network and things like that. So here we actually added some DHCP-v6 options because we think that enterprises will need these. It's a bit controversial, but I think we can make a good case that this is true for the majority of enterprises environments. Routers. Yeah, the basic things, the DNS options in the router advertisement. There's an RFC that basically says don't assume /64s because there's some equipment that gets very inefficient if your route is longer than a /64. And that can, for example, cause problems if you number point-to-point links with a /120 or 126 or 127. So, and again, also for these devices, there are some DHCP options that people might want. It's actually funny, the DHCP-v6 originally said, oh, we're not going to look at MAC addresses anymore because that's bound to an interface. We're actually going to look to the device ID because then we can distinguish which device it is, not depending on which interface it uses to get to the network. Of course, because IPv4, everything is based on MAC addresses, this created a big split where IPv4 was managed by MAC address and IPv6 was managed by DUID, and there was no correlation between the two, which made it actually harder. So, for example, some of the options are that the MAC address is actually included in the DHCP request so that the policy system can actually determine who's who. So again, some of those things seemed like a good idea at the time, but in the end it turned out that maybe sticking to those old MAC addresses wasn't so bad after all. So we didn't make those mandatory, but we added them as optional extra features that people might want. CPEs, consumer equipment. We just added the RFC that specifies the simple security capabilities that these devices need to have. Funnily enough, 10 years ago, there was no single RFC that actually specified minimal security requirements. So we thought it was a good idea to include those at this point. And then the biggest change, mobile devices. Originally, when we wrote RIPE 554, there was actually some interaction with the 3GPP crowd on what a mobile device should do on its cellular interface. It turned out after this decade, we actually don't know anymore, and we didn't have any connection with that community anymore. And we realized that maybe we weren't the right community to specify what a mobile device should do. So we decided to just get rid of the whole section. Now we treat mobile devices, if they have a Wi-Fi interface, they just behave like a normal host on the Wi-Fi interface. And the 3GPP-based standards for the cellular interface, those are not made in RIPE. Those are not, like the RIPE community has very little influence there. So we just decided to not include them in this document and leave that to other forums to specify that. Load balancers, very simple change. 10 years ago, everybody used the X forwarded 4 header. These days, there's an RFC that actually specifies a standard header with the same purpose, which is a bit more flexible. So we changed that. And then software. This is actually an interesting one. we didn't say much about software in RIPE 554, but this is a major pain point for a lot of enterprises. So we, instead of having some very vague requirements like, the software should work with IPv6 just like it does with IPv4, the user shouldn't really notice the difference, we actually put in some stronger requirements like all valid addresses must be accepted on input, the output must follow the recommended notation, DNS resolving must be implemented, connection sockets must be used. It's recommended to use Happy Eyeballs or Happy Eyeballs 2. And we made it explicit that this is not an exhaustive list, but these are really the minimum requirements that people should expect from software these days. So, I don't know, maybe we need to make this even stronger. And then we get to this point. It's still under discussion. This document isn't finished yet. It's still, we still call it RIPE 554 bis, because the moment it gets consensus, it will get a new number. Until then, we just call it bis. And it's still under active discussion. So I would like to ask you, take a look at this document, and if you have any input and suggestions, questions, please let us know, because this is a community document. This is what we think that enterprises and governments and organizations like that need from their equipment in these times. And like I said, it's very important because what is in this document will appear on the roadmaps of the major vendors, because there's a lot of uptake on these documents. RIPE 554 has been translated into a dozen languages. It's used all over the world and actually became like the standard to what to ask for. So we really want to get this right, because things that end up in the successor to RIPE 554 will very likely be implemented by all the vendors. So this might actually influence the direction that the IPv6 deployments in enterprises go. We have the document is a live document. It's on Google Docs, so you can see what's happening there. Go to the mailing list, ask questions, email us directly. We are looking to get consensus on this document at the RIPE 83, which is next week. So end of next week, it might be that we don't get consensus, and then we'll have to continue. But yeah, if you have any input, please let us know this week or the beginning of next week so we can actually implement it and use it. Sorry for the pressure. And that's it. Does anybody have any questions? Eggs, rotten tomatoes.
If anyone in the room does have questions, please come up to the microphone here. We have a question from the webcast.
Somebody asks, is there a plan to update this document on a regular schedule so organizations using it in their purchasing processes can always specify something fairly recent? Hopefully that would mean smaller updates, making the process somewhat easier.
Yeah, that's a thing that's been asked before, and yeah, we are a bit ashamed that it took us a decade to actually update the document. It also is influenced a little bit by how RIPE works, because RIPE documents, every new version gets a new number. So it's very hard to have one number you can refer to. We actually did talk about having like a live document that gets updated over time. But then you get the problem if somebody says it has to conform to RIPE X, that a person reading the same document a week later might get different content. So we do need stable identifiers, but having a completely different number every X months or years is also a bit difficult. So we try to find the middle ground. This way we definitely were too slow with updating it. So we will try to do it more regularly, but yeah, I also want to be careful with updating it too often, because then for enterprises a moving target is usually inconvenient. So, yeah, sorry, I can't give a more direct answer to that.
Hi, Greg Choules, currently ISC, formerly 3 Mobile in the UK. So the thing that you said about removing the section about mobiles completely because you just didn't have the expertise. The GSMA are quite approachable, you know, if you talk to them nicely. And, you know, having come from a mobile background where we did use V6 quite heavily, I think it would be an important thing to include, as in, you know, how do you guys actually do this properly and be standards compliant?
So yeah, we had the feeling that forums like 3GPP were more authoritative in this field. Mm-hmm. So we felt it strange as a RIPE community to list requirements there. But maybe there is one single set of documents in 3GPP that we just can refer to.
Well, I think it's probably useful that, you know, the GSMA themselves, you know, at times probably need some expertise input to them so that they can go, okay, this is how we're going to, you know, make the standard correct for this community of mobile users. You know, there are some things that you look at in GSMA and you think, yeah, you know, I wish you'd done that a bit better. You know, you'd had some more informed stuff, you know, back in the past. But, you know, so I think it's probably beneficial if something tries to happen there because, you know, the world is full of handsets.
Yeah, it's the majority of devices these days.
Indeed, yeah.
Yeah, thank you. So yeah, I'll take that back to the other authors, and we'll see what we can do with that, whether in this document or in some other way. But yeah, if you say that they can use some cooperation, I'm sure we can find a way to do that. Thank you.
Any other questions? Thank you very much, Simon.
There's a number of questions in the Mattermost
Oh,
channel.
we missed some questions in Mattermost.
I don't see. I see one from. I don't know how to pronounce the actual username. Livagoria. I'll try that with, but I don't see any other. What are you seeing, Keith?
That sounds like Leo Vigoda.
Probably. I apologize for the butchering of the name. Okay.
Keith, can you see? Do you have the question? I'll repeat it.
Okay. Question from Leo Vigoda. Is there a plan to update the document on a regular schedule? So we're going to
Yeah, we just had that one. Okay, no worries. But yeah, it's a difficult subject. I'll have a chat with Leo.
If that's it, thank you very much.
Thank you.
We're running a little ahead of schedule. We are going to continue, though, going with the timetable, which means we'll have a longer break until 3:30. In the meantime, I'd like to thank our sponsors, LoanApp, and the individuals who've contributed, our premium patrons, Flex Optics, IPv4 Market Group, and the RIPE NCC, our promoter patrons, Hilco Streambank, ISC, and Scrutiny, the support of the Friends of UKNOF, and our partners, Bogons, doing the video casting, and Portfast for connectivity. Thank you, everyone. See you at 3:30. We'll be starting in about 1 minute. Welcome back to UKNOF48 here in Manchester and hybrid online as well. Our next speakers are Elena Sanchez and Jose Leitao from Meta. They are going to be talking about an evolution of the network engineer. And they're joining us remotely, hopefully.
Everyone.
Hello,
Thank you
Elena.
Hi. I also have Jose with me here today. So,
Hello.
Hello. Are you both ready?
Yes.
yep.
Excellent. I'll give the floor to you.
Great. Thank you. So hello, everyone. Good morning, good afternoon. And first of all, thank you again for having us. It's always great to come to UKNOF, even remotely. I'm Jose from Meta, also formerly known as Facebook. And today, along with Elena, we are presenting our perspective on the evolution of the network engineer role. Next slide, please. If we go back into the past, specifically when I started my career as a network engineer, one of the many questions I had was around what was the core knowledge needed to be successful? What was needed to be able to do most of the projects that would come my way? What was essentially fundamental versus just something that was nice to have? And although I don't know if I ever looked as happy as the person on this slide, I ended up developing this knowledge with experience and the available resources I had at the time. Next slide, please. And if we oversimplify, it looked a bit like this. There were some critical intersections between these three domains, protocols, topologies, and how they would normally be used on the internet or on the particular use cases I had to use them for. Next slide, please. And depending on the type of role or depending on the type of project, these other three skills were also pretty fundamental. The concepts of power, space, cooling, different redundancy modes at different layers, and what the hardware could and could not do. Next slide, please. So, oversimplifying again, those cover most of what a typical engineer needs to know to be effective. But what's the difference when we are operating at scale? What's different in an environment such as Meta? To describe this better, I always like to call out on some fun myths, and I have a few, but just for the sake of time and the length of this presentation, I will only cover one of them with a few examples to illustrate the point. Next slide, please. And the first one, and the one I'm going to cover today, is essentially this myth that big networks have fixed everything. And I would love for this to be true, but it's not. Next slide. I would love that essentially this is how I looked every day, but the reality is a little bit different. And if you ask me, more interesting. Next slide. So if we look at this graph, which comes from a book humbly called How to Change the World, this graph shows an adoption curve. If we look at it from left to right, most environments such as ours typically are doing projects in one of the first three sections, the initiators, innovators, or early adopters. The reasons for this are varied, but they come down to the fact that when you have thousands of anything, any optimization becomes really meaningful. And new technology enables kind of new possibilities, which we are always evaluating as they present opportunities to shift some of the trade-offs that we have historically made when building the network ecosystem. And some of those shifts have pretty meaningful and pretty deep impacts in one of the valuables that we always consider. Next slide, please. One of the few consequences of this is the fact that the network keeps changing and it rarely looks as a monolith. We have a varied ecosystem that has many permutations of network devices and network operating systems as those fulfill a particular business need for the different spaces that they operate on. And I know this sounds somewhat abstract, so I'm going to talk about a few examples. Next slide. So keeping in mind this diverse network ecosystem that I was describing, let's discuss how do we get information out of devices. This is, I would say, normal and pretty vital. And this data ends up feeding most of our automation, and even like the rare case when we have to do kind of manual troubleshooting or some form of manual analysis. So depending on what network OS you're running, these are some of the different ways that you can interact with it, right? You have some of the classics like SNMP or TL1 for everybody that has optical platforms. And you have some of the more modern options such as Drift or gRPC or whatever your favorite vendors call streaming telemetry these days. But the fact of the matter is that this presents a non-trivial challenge for the teams operating these fleets. There needs to be a comprehensive and modular framework that allows extensibility, control, and a support for a multitude of ways of interacting with the devices. And interesting enough, keep in mind that we are only talking about read operations. We're only talking about extracting information out of the devices. Next slide, please. And of course, we want to do this without having to essentially screen scrape with regex all the things. Next slide. The same challenge is present when we think about another common operation in the lifecycle of any platform, such as upgrades. Similar to data collection from before, different operating systems will have different ways of doing upgrades with significant constraints attached to that process. Those constraints can range from how do you preload new code to the complexities involved with removing traffic from the device and ensuring it is healthy before restoring it. And this is without taking into consideration that some upgrades will not only be kind of like the software load, but like it will also touch firmware components that have like specific orders of operations, or some of those operations take a really long time. Next slide, please. And my last example is a bit more difficult with a use case for probing software to detect broken devices. This would be the systems that use some capability in that platform or in that topology design to probe if a device is performing correctly with synthetic traffic. The complexities of hardware data forwarding and control plane policing, just to call out a few, make building and maintaining these solutions pretty challenging, especially if you're trying to develop these capabilities in a universal fashion, which is usually what you're trying to do. And with that, I hand off to Elena to discuss how we are bridging some of these gaps with our engineers. Next slide, please.
Thank you, Jose. Okay, so I'm going to really delve deep into what happens or what we have seen so far when we have engineers joining teams at Meta and they have to deal with some of the challenges that Jose was mentioning. So next slide, please. So this is how those gaps start to manifest. Then we can talk about some ideas to bridge the gaps. So the first gap that we saw, or we see usually, is that software development is not usually part of the core component of the day-to-day life of let's say super traditional network engineer. So how is the gap manifested here? Next slide, please. Then the way that you can see it is like they struggle with writing code that is reliable, but also a solution that can be deployed at scale. So next slide. The other one is more about the incomplete knowledge of maybe fundamentals. So sometimes you might know about one protocol, but maybe there are some gaps of knowledge there. And the way this is manifested, next slide, please, is the part that we have seen in terms of implementing those fundamentals when they are, when you have to propose some solution at scale. So that's when you start looking at, okay, there are some gaps here. Maybe the protocol that they were working on a small network, now that gap is reflected when they have to design for like, thousands or millions of users. Next slide, please. The other gap is interesting because it's about monitoring. So in the traditional, let's say, environment, maybe there is a lot of manual monitoring, manual troubleshooting. The fleet of devices maybe is very small, so that's okay and normal. It's not terribly, it's not bad. But the gap here is that the way to solve problems could be or tends to be something more manual, because it might be faster just to try to automate a script if you only have a small fleet. So next slide, please. The opportunity here is like, actually it's a missed opportunity to kind of introduce some sort of a standardization, the way we gather, the telemetric or the data from devices or from different parts of the network. And that's one of the first kind of gaps that we see. But then the other gap could be more, okay, how do you go and automate? Now that you have standardized, how do you automate all this? So that part of kind of like a day-to-day mindset that you have or you have to have in big networks just because of the scale, that's not necessarily present on the day-to-day work of a traditional role. And that's one of the points that we have identified. So next slide, please. So here are some ideas that we also tell people when they really want to pursue the goal of, okay, I really want to work at scale. And so bearing in mind those three gaps that we are mentioning, the ideas will be the following. Next slide. So for the first one is to try and make automation part of your kind of day-to-day role in some way or form. So getting familiar also with unit testing, integration testing, things that, maybe when the scale is not that big, you are okay by fixing things on your own and manually fixing that. But when you have to deploy code like reliably across a huge fleet, having some tests, it's very, very important. Next slide, please. The other one is to feel or to get comfortable with some programming language so that, but really try to implement that and use it on a day-to-day basis as well. And understanding what are the use cases per language. So maybe Python might be a good one to start, but maybe you need something like Go or Rust, depending on the service that you're developing. So trying to understand what are the pros and cons for a specific language, for a specific job or I'll say like outcome. So next slide, please. Another is really try to understand one, let's say, get your favorite protocol in depth and refresh the fundamentals as well, so that when it comes to, even like interview process and things like that, you have a better understanding on how to apply this to solve for a massive scale. And for example, or you can look at this as what are the limits of a protocol? How does it fail? What happens when it fails? Also, how would it work in a real world if you have to support, millions of people and so on? And next slide, please. Here are some really good books that we tend to recommend. I mean, we are not sponsoring them by any way, or they don't sponsor us by any way, but there are just a few good books. For example, Clean Code, How to Measure Anything, really that one is a very interesting one to get this mindset of, when people say, oh, this is very hard to measure, it cannot be measured. That book really gives you an interesting perspective. Then Think Python, An Introduction to Software Design. And then Network Programmability and Automation. So those 4 books are really good if you are thinking of, okay, how can I evolve my role and what resources can I start reading or getting familiarized with? Again, these are not the only books that are in the world, but they're very useful if you are looking at continuing that path. Next slide, please. Now, I wanted to talk about how we are approaching this problem of, trying to get talent, but also trying to help people grow into this evolution of, okay, I work manually, I do my configurations manually, to a world in which that wouldn't be possible just because of the scale. So how are we trying to look at this problem? And the way we're doing it is by kind of creating a program that can help people define their careers, but also teach them all of these skills. Next slide. And this is how we call it, the Rotational Network Engineering Program. So this is the one that we have developed at Meta. Next slide, please. And the idea is that we boost the career progression. So we give engineers enough time to, get used to with our tools and our, the way we work at scale. But the idea is that as soon as they join, they have a platform to grow. So next slide, please. So we not just help them, but also we find people that have this talent or knowledge. They know about software engineering, but they're interested in the network, but they don't know exactly how to, get into scale and work at scale. So that's kind of one of our looks, but also we look at people that are, let's say, network engineers who are kind of like very interested in solving problems with software and at scale, but again, they don't know how to enter that world. Again, those are kind of the two pool of people that we really try to help bring in and also grow. And next slide, please. And the way we do it is that we give them some time to work on broad tasks. So they learn about different domains and topologies and so on. And then they go deep into a domain with a project. And next slide, please. And then we also focus on not just the technical side of things, but also what other skills they have to learn. So for example, working cross-functionally with partners, understanding how to communicate with other teams, all of the skills, including like persuasion, discussions, and how to be effectively, or how to work effectively as an engineer. Next slide, please. Finally, we also give them some support with mentors and also with, kind of like other former engineers that also went to their program. So this is the way we are looking at how can we get people that are not that familiar with scale, and at the same time, they're developing their skills and get them to a point that, okay, now they can join a team, I don't know, let's say in the backbone, and they feel like able to contribute and continue developing some features and also solutions. So yeah, so that would be it. Next slide, please. Thank you very much. I will leave some time for questions. Yeah, but thanks.
Thank you, Elena and Jose. If there are any questions in the room, please do come up. Otherwise, if you've got questions you'd like to either ask anonymously or you're watching via webcast, please do type them in the Mattermost channel. There is also a survey question that will be popped up in the Mattermost channel if you can choose one of the options to rate the talk.
Hey, hi, Jose and Elena. Thanks for the presentation. I'm Hari. I'm from Benox. We all know probably there were two important dates in Facebook's history this year. One was the renaming of Meta, but the other one was the infamous outage. I just wanted your perspective as a network engineer. What were the learnings probably from the outage, and was that a motivation for this presentation?
You wanna take this, Elena, or should I?
I can answer the part of the presentation if this was a motivation, and the answer is no. The outage is not a motivation for the presentation. We have been, the rotational program and the evolution of the engineer and the gaps that we have observed have been there since a long time. And this is more us trying to, okay, what can we do to bridge the gap and help people? So on that regards, the presentation was already there before of the outage. Do you want to take the first part of the question, Jose?
Yeah, so thank you for the question. Yeah, definitely that event wasn't great. And I think it's interesting because, you know, we made a blog post that describes a little bit what happened, which essentially, you know, something that was kind of supposed to go, you know, to a very limited number of devices on the backbone, basically went everywhere, and, you know, caused kind of everything that came after. So we definitely are, you know, hard at work on some of the, you know, we already completed most of the immediate follow-ups for that. But, you know, it's always like we have this, you know, we have this incident management programs, right? You know, we have this blameless culture that we had since a really long time. And we basically go through the same process with every incident, including this one. And, you know, we always try to extract the maximum value and the maximum learnings, and, you know, obviously adjust accordingly. And that's what we're doing. So, you know, we've done a lot of the immediate short-term kind of follow-ups, and, you know, are now kind of doing roadmaps and, you know, working on longer-term projects to cover some of these gaps that, you know, interestingly enough, some of the things we mentioned in the presentation are part of this, right? And, you know, they're part of any sort of fundamental development for systems, right? Which is like, well, how do you ensure that, you know, you can validate all your different assumptions, and especially when you have kind of an ecosystem that's formed not only about like this, you know, multiple diversity of, you know, devices and operating systems, but also kind of like on top of it, you have a layer of software systems that are, you know, interdependent with each other, and that you, you know, are able to effectively manage that complexity. So yeah, it's ongoing work. Reliability never ends, right? It's similar to security. It's an ongoing, ever-present thing that you need to keep in mind and, you know, act accordingly.
Cool, thank you.
Do we have any other questions for either Elena or Jose, or both of them? None in the room either. Okay. I'd like to thank you both for a fascinating talk. Really enjoyed that. Thank you.
Thank you very much.
Our next speaker is also joining us remotely. Rebecca Klaas-Peter from EuroIX is going to be talking about a new kind of peer. Okay.
Before I go to talk about what the peering tool. Good afternoon, everyone. I'm very happy to be presenting at UKNOF48 in Manchester, which is my home city. My name is Rebecca Klaas-Peter, and I'm the Events and Operations Coordinator for EuroIX. And today I am going to be presenting on a new kind of peer, introducing the peering toolbox. Slide 2, please. Before I go to talk about what the Peering Toolbox project is, I'd like to give a little bit of background about why it was created. So, you know, we all understand the traditional role that ISPs played in providing internet transit to organizations in the early days. And some of the reasons for this is that many of those organizations did not know what was involved. The PTTs were much bigger and the cost importance of the internet was unknown. Now, the internet has become an essential part of every organization's services, so they are taking more control over it. Businesses have needed to optimize their services. For example, if you are a financial service provider, you need really low latency to other financial service providers, or very high availability to those financial service providers, and not just a generic internet access, but targeted services. Slide 3, please. So what's the problem? The problem is that there's growth in the maturity of the need. And this is the main driver for the enterprise networks to manage their own connectivity. And this brings some risks to both them and their existing internet providers. They know that they need more than just transit, but they don't necessarily have the in-house expertise at being an internet network. Their expertise is being a transit customer, which is much easier. And as a transit customer, you send everything to your upstream and you trust your upstream to do the appropriate filtering. And if there are any issues, there is a system in place to resolve these issues. Now, there is more than one vendor. You are now peering at links or LANAP or whichever IXP is relevant to your organization. And the vendor and their peers expect you to know things. They expect you to know things and you may not know them. Slide 4, please. So now getting from one place to another for an ISP is your cost of business. But if you can peer, you can do that more cheaply and lower your cost. Obviously, there are different kinds of lowering cost, but IXPs lower cost across the board, including transit cost, but they are now operational cost. The cost of the business is not latency or transit, but operational in that it's the cost in expertise. Now that these organizations are peering on their own, they have technical teams, but these technical teams may not have the internet engineering experience, and there might be things that they don't know. For example, they may need to have a working abuse system. There is also a reputational risk, as it's fundamental that these enterprise networks maintain their credibility as part of the internet infrastructure system. On the other hand, you also need to decide who you're going to pay with, depending on the type of service you're offering. And as every peering session needs to be monitored, these businesses need to be very careful about who they're peering with. Otherwise, this results in an increase in cost by hiring more people. Additionally, also, an ordinary network will be taking on a risk by peering with a new organization, as this organization may not have the cultural background that an internet historical network will have. They are more likely to have, less likely to have standard procedures and more likely to have outages. Slide 5, please. So what is the solution to this? And this is why we have introduced Peering Toolbox, which is a new service for the community by the community. Slide 6, please. So what is the Peering Toolbox? It's a community-focused Euro IX project. It was created with organizations such as Lynx, NAP Africa, Microsoft, Amazon, and INEX. And the idea of the Peering Toolbox is to identify and develop the key areas of knowledge and skills that are useful for peering coordinators, and also develop and bring together various tools that will help to upskill those who are in or new entrants to the peering industry on the best practices and to provide various how-to guides. Slide 7, please. So with the Peering Toolbox, we are acknowledging that there's already a lot of good work out there by the community. And what we are hoping to do is to fill in the gaps in practical information and peering. It's not to have a commentary on what's good or what isn't. We're not creating a peering Bible. What we are doing is making all the good work that's already out there by the community available in one place. So we also want to shout out James Bensley, who has sent us a great document on how to make decisions. And we are hoping to integrate that into the Peering Toolbox website very soon. So if you also have good material on peering practices, please do get in contact with us, with the Peering Toolbox team. Our email is on the slide. We'll be very happy to have a chat with you about, what you have, and then link that material on the Peering Toolbox website. Slide 8, please. We're also in the process of creating a Peering Academy. And what this Peering Academy will do is to create a learning structure for new entrants to follow and discover what they need to learn to make the best decisions for their network. So this structure will cater to whatever level that you're at, whether it's beginner, intermediate, or advanced. We're also going to use the IXPDB to see the types of networks that are connected, which will help give some insight into their knowledge. We are looking to build up the Peering Toolbox team. So if you're interested, if anything that I've said has been interesting to you, or you would like more information on the Peering Toolbox, please do contact us. As I've said, the email is on the slide, and we'll be very happy to have a chat with you. Slide 9, please. So with that, I conclude this presentation, and I'm open for any questions. Thank you.
While Brandon links us up with Rebecca live, just a reminder, there is a poll in Mattermost. Please do rate the talks. It's very useful feedback for both the speakers and the programme committee. If we do have any questions, please do come up, or again, type in the Mattermost channel and Ben will raise your question. Do we have any questions for Rebecca about the Peering Toolkit and EuroIX's strategy there? No questions on the stream? Nothing yet? None in the room? In which case, I think we'll call time and say thank you very much, Rebecca. Thank you for sharing what EuroIX is doing. Again, we're a little ahead of schedule. We will... Oh, a question has just come in. Go on.
So Peter Hessler asks, this project sounds like something I would have loved to have access to when I started doing networking. Is there information already available to look at?
Yes, there is. There's some information already on the Peering Toolbox website. And I can put that in the UKNOF chat in a minute. But, a lot of good work has been done already. So we've already got some material from like RIPE NCC, DKIX, and some other organisations, NAP Africa. So we're just gathering all the information that's relevant to enterprise networks for peering coordinators as well. So it will all be in one place. So we do have some information on there already, but we're hoping to develop this in a very structural way for everyone to access the information in an easier manner. I hope that answers the question.
I think it does. Just there's a transmission time between the web stream, which I assume Peter is listening on, but thank you.
Thank you, Rebecca. In which case, we'll continue with the rest of the programme, which is right now going to be a break until 4:45, 16:45 UTC. Before I let you all go, I'd just like to remind you that UKNOF is sponsored by LoanApp and a number of individuals, a number of premium patrons, Flex Optics, IPv4 Market Group, and the RIPE NCC, and at the promoter level, Hilco Streambank, ISC, and Scrutiny. And currently, UKNOF is looking for additional patrons to support the future events. If you could contact the team on the email address patron@uknof.org.uk, the team, Dinesh in particular, will be very happy to explain what's involved. And again, I'd like to thank our partners, Bogons, for the video streaming and Portfast for the connectivity. Look forward to seeing you all after the break at 4:45. Thank you. Welcome back, everyone, to the last session this afternoon on the first day of UKNOF48. I'm very pleased to say that we've had over 230 playbacks of the stream, which leads nicely into the next talk, although I don't think we're quite yet at the scale where we're going to need a tree-based CDN for live streaming to mass audiences. But that's the next talk. Lenny Giuliano from Juniper Networks is going to be talking to us about TreeDN.
Thank you. And don't sell yourself short with high bit rates. You might just need it soon enough. So I'm going to talk today about, my name is Lenny Giuliano from Juniper Networks. And I'm going to talk about today TreeDN, which is a CDN architecture optimized for mass audience live streaming. So let me start this talk with 3 questions to keep in mind as we go through this presentation, and I'm going to kind of address each of these 3. First, are we approaching an inflection point for network resources based on what's going on with live streaming? Second question is, if not, will we ever? And if the answer to either of those questions is yes, what should we do about it? So first, let's just look at the numbers for streaming, live or otherwise. When it comes to high def bit rates, it's about 5 megs per stream. 4K is about 8x that. 8K is about double of that. And VR is astronomical. VR, AR, the numbers are all over the map, from 0.5 gigabits per second to 5.2 gigs per second. Now, Akamai, which I believe they're one of the biggest, if not the biggest CDN provider on the internet. Every year they announce that they've broken a new record for the most amount of traffic sent simultaneously on the internet. The last time I noticed the number was 167 terabits. That was the most traffic they'd ever sent all at once. So just for fun, if we divide 167 by 40 megs, just to see how many 4K simultaneous streams it would take to break that record, the answer is about 4.2 million. And to give you an idea, 4.2 million would correspond to the 117th most popular television show. So that's the predominant method for delivering content today is unicast, brute force unicast. If you need to send 10 streams, if you have 10 viewers, you have to send 10 streams. If you have 1,000 viewers, you have to have 1,000 streams. So this brute force unicast method, can it keep up? It seems to be working just fine right now, to be clear. But the question is, can it last forever? Just to give you some more numbers, the average NFL game, which is American football, has 15 million television viewers. That's an average game, not a marquee matchup, not a playoff game, not the Super Bowl. If all 15 million viewers were watching at 4K at 40 megs, that would be about 600 terabits. So we're talking one game would be 5x what was previously announced as the largest amount of traffic by the largest, one of the largest, if not the largest CDN providers. And for those of you who, wondering, the latest NFL deal actually includes games that are available exclusively only through streaming. And it goes up from there. The Super Bowl has about 100 million viewers, simultaneous viewers. The 2015 Cricket World Cup had 2 to 3 times that. And the last World Cup in soccer or football, as you call it, had about 500 million simultaneous viewers. Also, the cord cutting evolution probably began, 12, 13 years ago with Netflix and YouTube and Hulu. And it was really all about on demand, watching shows when you want on demand. But the evolution and all the excitement is really about capturing that last bastion of folks who haven't cut the cord and are still paying their cable bills. And that is live linear television. And where you see with companies like YouTube TV and Sling TV and Hulu TV, and it's about going after those last holdouts. And in a word, it's about sports. If you want to ask, does anybody still watch live linear TV? The simple answer is sports. So live linear TV is not dead yet. And in fact, it's actually trending. We live in a fake world, the fake news and deep fakes, a low trust world. where, you know, the typical corporate communications of any large company looks like it was torn straight from the pages of Orwell. So it's a low trust world that we live in, and due to the spontaneous and uneditable nature of live streaming, it's perceived as more authentic and more emotionally engaging than on demand. I mean, that's probably the reason why I'm speaking to you live and not just a 25-minute recorded presentation that, you know, then I appear at the end to give to answer questions. For some reason, live is just more interesting and emotionally engaging, and marketers have known this for a long time. People spend more time with live videos than on demand. They're more likely to make purchases, and the ROI is much higher. And the COVID pandemic, prior to the pandemic, live streaming was the fastest growing segment of online video. The pandemic has only exploded that for things like e-learning, fitness and wellness classes, conferences like this, worship services, sporting events. You know, these are huge drivers, and the numbers bear this out. The numbers are just astronomical from the beginning of the pandemic onward. I would point out live streaming e-commerce is absolutely explosive. The numbers are just mind-blowing, and it's tough to imagine in China. But this is huge in China. So live linear video is here to stay. It's not going anywhere. The problem is the internet is based on a unicast model that is well suited to pretty much all traffic except multi-destination. This is why multicast was created more than 2 decades ago to solve this problem. So what went wrong? And I'm going to talk here and focus here on internet multicast because multicast is widely deployed in certain places, in walled gardens for video distribution, for financial networks. Multicast is huge. But on the internet, it never gained the traction that its advocates hoped. So why? Well, let's go back to the beginning. And in the beginning, there's unicast. And if you have interested receivers, they get a separate data stream for each of these live streams. And you can see very quickly, this gets costly for the source. The source needs a server big enough to push out all of those sources, all those streams to each of those receivers, and needs enough bandwidth to send it to each of them. So along comes multicast, which allows the network to discover all of the interested receivers, builds a tree just to those interested receivers, and delivers the content such that no one link carries more than one copy of the data stream. But there's an obvious problem with multicast. First of all, the internet is not a monolithic network. It's a network of networks. Some of them are multicast enabled. Most aren't. So if you have a source on a multicast enabled network and you have a receiver on a unicast only network, the result is unbounded sadness. Sadness on the part of the receiver who can't receive this content. Sadness on the part of the source who has an interested receiver, is able to multicast, but can't deliver that content. This is known as the all or nothing problem. Every link from source to receiver must be multicast enabled in order for multicast to work. What that means is every router and firewall on the internet needs to be running PIM or MLDP or some type of multicast routing protocol. That's a really high bar. So as a result, CDNs came along, and there's different models for CDNs, but just one popular model is you deploy these boxes, these CDN boxes throughout the network, deliver the content to each of them, and then they handle local receivers. It's almost as good as multicast, and it just works. You don't need to turn PIM on every single router and firewall on the internet. So if we compare these 3 delivery mechanisms, unicast, CDNs, and multicast, and we look at cost as a function of audience size from the perspective of the content provider, and that's important. Think about this from the perspective of the content provider. For unicast, it's simple. You have 10 viewers, you got to send 10 streams. You have 1,000 viewers, you have to send 1,000 streams. For CDNs, there is still a per user cost, but the cost is much lower. So the slope of this line is much smaller. But do notice that there is an initial cost, and that's the cost to rack and stack those boxes, power them up, plug them into routers. By comparison, multicast, whether you have 1 viewer or 1 billion viewers, the cost is constant. So the marginal cost for each additional viewer is 0. And again, this is from the perspective of the content provider. That's an important distinction. The important thing to note here is CDNs don't eliminate the brute force unicast problem. They just distribute it. So there's an agency, a satellite agency out there called UMetSat. They basically do atmospheric They're an atmospheric and meteorological agency in the UK, in the EU, and they are streaming meteorological and atmospheric telemetry data constantly in real time, high bandwidth streams. These are like 150 meg streams, and they're constantly sending those out to research institutions. And they're doing it via multicast. They're doing it in multiple ways, but one of the ways they're doing it is real live interdomain multicast. And they've said that if they were to do the same thing with unicast CDNs, it would cost them an order of magnitude more expensive than doing it with multicast. Just as a technological aside to those big fans of V6 out there, and I'm sure you're out there, the folks who really are strong advocates of V6. I think multicast and V6 are related. I would call them technological cousins, in that any argument for and against V6 kind of applies equally well to internet multicast. The folks who say you don't need it, for V6, we've got NAT. Why do we need V6? Same thing goes for multicast. Why do we need multicast when we've got CDNs? On the other side, the advocates would say we absolutely need V6 because we've exhausted V4 addresses. Similarly, multicast advocates would say, duplicated video streams are incredibly inefficient. Both suffer that same all or nothing problem that I mentioned. Both require new protocols or extensions of old ones. Both were born around the same time in the 90s, struggled through adolescence. And while V6 is certainly doing better than its multicast cousin, I'd say they're both still living at home with their parents, who are kind of nervous and concerned. Both require faith in the unseen, in that alone, they do nothing, but they enable bigger things. So what's new? Internet multicast has been around since the 90s, hasn't gained a whole lot of traction. Why will this time be any different? Let's start with the three problems of multicast, the three biggest problems of multicast. I've talked about the all or nothing problem. The second one is multicast is too complex. Service providers, network operators have been complaining for decades about all the complexity of multicast and getting it working, and all the headaches to configure it, to troubleshoot it, to manage it, to operate it. And the third thing is there's a chicken and egg problem with content and audience, where there's no audience because there's no content, and there's no content because there's no audience. All right, so here's what's new. And there are new developments that address these fundamental issues and kind of take them off the table. So most recently is ASM deprecation. This is a relatively recent RFC, BCP level RFC, that essentially says, stop doing ASM. And ASM is the traditional model that supports both one-to-many and many-to-many, and just do SSM. It turns out multicast isn't complex. ASM multicast, any source multicast is complex, and more specifically, source discovery, network-based source discovery. If the network is responsible for discovering the sources, that's where all of your complexity lay. So if you just do SSM, you take source discovery out of the hands of the network, put it in the hands of the application layer, you can eliminate about 90+% of the complexity of multicast. You get rid of rendezvous points, MSDP, PIM register messages, NCAP and DCAP, shared trees, tree switchover, all of those things go away. And with SSM, you're left with PIM SSM is about as complex as LDP. And nobody complains that LDP is too complex. This BCP is applied already in Internet 2. And this solves that fundamental, problem number 2, multicast is too complex. The second thing is overlay networking, and specifically automatic multicast tunneling. So when I started in this business in the 90s, tunneling was a suboptimal hack, something to be avoided, something to be eliminated. It turns out if you just rename it from tunneling to overlay networking, all the cool kids are doing it. So it's now fashionable. And it solves the other two problems. One, the all or nothing problem, because we can tunnel over the routers that and firewalls that don't support it. And it also solves that chicken and egg problem by now making the audiences potentially anybody on the internet. So all the pieces are in place, and I'm going to kind of demonstrate what they look like. So what is AMT, automatic multicast tunneling? How does it work? So let's start with a multicast enabled service provider. There aren't many, but they do exist. Think GIONT, the Research and Education Network of Europe. And imagine a multicast enabled content provider, not many, but they do exist. UMetSat is a perfect example. And imagine a multicast-enabled local provider. Again, not a lot of them, but they do exist. Most commonly on the RENs, the research and education networks, the regional RENs and the national RENs. So imagine you have multicast stream with a bunch of interested receivers. They will receive it natively the way we all understand multicast to work. But imagine a unicast only network. The other 99 point something percent of the internet is unicast only. So imagine you have an interested receiver who sends an IGMP report to their last hop router, and that last hop router is not running multicast. So now what? Well, if this client, and this client could be a laptop, it could be a smart device, a phone, cell phone, an iPad, whatever, a smart TV. If it has this AMT client, AMT gateway client, which is a thin client, that is able to magically discover the nearest AMT relay, which is a special box that sits at the border of a multicast enabled network. And it can dynamically discover and build a UDP tunnel to that relay, and then send an IGMP report through that UDP tunnel. The relay in turn receives that IGMP report, joins it natively through something like PIM, and takes that native stream and sends it over the UDP tunnel to the gateway. As we have more and more clients interested, they receive separate tunnels. Now we see also the unicast only network finally has a reason to actually turn multicast on. Previously, because of the chicken and egg scenario, why would a unicast only network operator bother with the hassle of turning on multicast when nobody's using it and there's no content out there? Well, if all of a sudden a zillion duplicated unicast streams are going over the network, finally there's a business case and a reason to turn on multicast. And this is the key thing to keep in mind as AMT. It is a stopover. It is a transition point. It is not a destination. It gets you from to go down the path of going native. Now, there's always going to be parts of the infrastructure that are not multicast enabled, and that's AMT. So AMT is always going to have a place in networks, but for the most part, the goal is to get you to the next step, which is native, and to motivate. So let's go back and look at CDNs without multicast and compare CDNs to multicast. So here's a CDN without multicast. Remember how this worked? Now, if we add tree DNs, which are CDNs with multicast trees, we send first we change those CDN boxes and we call them AMT relays, and we send content from the source to those AMT relays via multicast, and from there they handle local receivers. What are the big differences? First, we can move the replication point closest to the receivers, as opposed to those boxes sitting in POPs somewhere, perhaps in the middle of the network or close to the edge. This can be pushed out to the furthest edge of a network operator's network. Also, the content only goes to relays that have interested receivers. So if you're a relay and you have no interested nearby receivers, you're not going to get this content. Also, if these relays, if you have edge routers, which are AMT capable, and this is a capability that is available in many router platforms. Essentially, and particularly, one that I'm well aware of, it's only 4 lines of config. There are no blades, no extra licenses, no extra hardware, no servers to rack and stack and plug into routers. This is an existing inline capability on existing routers. So essentially for zero CapEx, you can offer a replication service to your customers, and potentially zero OpEx because there's no cost in new power, space, bandwidth, depending on how you measure OpEx. You could argue that it's zero OpEx as well. So think of it as a CDN on a chip. So I'm here to tell you that this isn't just a wishful hope for a distant future. We've actually built this and it's available, and you can see this in action. And I'm going to send you some links where you can check it out. So the TreeDN architecture kind of has 5 steps. Well, as all great big grand plans have 5 steps. The final step being, of course, always profit. So let me go through each of these. So in terms of relays, we currently have on the internet 4 AMT public relays deployed on the MBone being the multicast enabled part of the internet. They are at Internet 2 members who have basically turned their peering router added those 4 lines of config and are supporting multicast. We'd love to have more. So if any operators are interested, we've been talking to other RNE institutions in both Internet 2 and Giant, and they have expressed interest. But if there are others in the audience, we'd love to talk. And in terms of how do you discover those relays, the 4 relays, we basically use DNS. So we have 4 separate A records for a single fully qualified domain name. And we hard code the application layer with that fully well-known DNS, fully qualified domain name. And in the case of VLC, it essentially receives all 4 A records and goes one by one till it receives traffic. So in this way, we can get resiliency and redundancy. Not necessarily optimality, but we'll get that later. All right, so how do we watch it? You need gateway implementations. The goal and our hope was to have this available in a browser, but browsers are pretty well locked down these days. They don't even support UDP. If you can't do UDP, you certainly can't do multicast. So our second best option was to do VLC. It's a distant second, but it's a solid second because VLC is open source, very multicast friendly, and it is fairly easy to use and reasonably well deployed. So we now have an AMT gateway implementation. It's been upstreamed in VLC, and you can download it and check it out. In the meantime, there's work being done led by Jake Holland at Akamai and others at both IETF and the W3C to do the things needed to get AMT, to do the things needed to get multicast supported in the browser. That's what we really need. In the meantime, VLC is good enough. All right, so if you have a relay, you have a gateway, how do you find the content that's out there? And so there's a multicast content portal. This is called the multicast menu. I would encourage everybody, check this thing out. It works and it's pretty cool. And it was written by a high school student, Lauren Delwich, at Thomas Jefferson High School in the US, right near Washington, DC. It was built on an earlier script that was written by William Zhang, a student who began the journey. And he was the one who deployed the first AMT relay at Thomas Jefferson High School. And it basically crawls through all the looking glasses of I2 and Giant routers to find multicast streams of a certain bandwidth, and then populates them on a web page that you could click and launch VLC to watch them. And you can manually add content. The next thing is off-net sourcing. This is where things get really interesting. So we've been talking about off-net receiving, where you have receivers who are on unicast-only networks, and how do they receive multicast content? But what if the source is on a unicast-only network? What if you wanted to take your smartphone and start hitting record and streaming at 4K or 8K to an arbitrarily large audience of thousands, tens of millions? So the idea is, what if we had a translator that sits at the border of the end bone, taking in a unicast-only stream, turning it, translating into a multicast stream, and spitting it out into the network? And we've actually demonstrated this earlier this month at IETF, and you can check that out. So if we put it all together, here's the big I internet, mostly unicast enabled. The M bone is the multicast enabled part of it. We have a native source, native receiver. It's received the way multicast has always, we all understand it to work. Now imagine you have a receiver on a unicast only network. We deploy relays, send it natively to the relay, then tunnel it via AMT to those receivers. And imagine you have an off-net source, a source on a unicast-only network. That source will send the stream via unicast to a translator who basically nats it, the destination and source address, and then it can be received both natively and off-net. All right, so what's in it for operators? Why would you want to do this? Well, remember the question I began. Are we approaching a point, an inflection point, where audience sizes are exploding, where bit rates are exploding for things like 4K, 8K, and VR, that we should begin to think about a new way to distribute this? This provides an ability for operators to create a viable business model for live streaming to mass audiences. The costs are a fraction of what unicast-only CDNs would be. There's no new servers, no blades, nothing to rack and stack. If you have the routers that are capable of it, it takes 4 lines of config. And that's it. And all of a sudden, you can offer a new replication service to your customers. And the market for mass streaming could be huge. The last thing is, this gets us back to our roots of a decentralized internet. Is it healthy for the internet and society that pretty much all of content distribution is controlled by a handful of companies? Is that good for the world? This architecture allows networks, allows us to get back to that decentralized model of the internet. For further reading, here are the references. And I encourage folks to check it out. And if you're interested and you want to get involved in this project, and you want to join our merry band of co-conspirators, shoot me an email. We'd love to have you. We have a Slack group, and we're working on constantly improving this network. With that, I'd be happy to take any and all questions you might have.
Perfect timing there, Lenny. And you've got me convinced, especially with that argument about, IPv6 and the parallels. I'll certainly be getting in touch. Are there any people in the room that would like to ask Lenny anything else about TreeDN and AMT? Or indeed in the web chat?
I will ask one for myself.
Go for it.
So how do we, I haven't seen multicasts, I mean, I'm young, so I haven't seen multicast CDNs, or sorry, multicast backbones operating with my own eyes. How well protected is multicast and the various protocols around it from things like reflection attacks? How, could you accidentally subscribe your victims to a bunch of these relays and absolutely pummel them to bits?
So that's kind of an implementation question for the relays. And there are, and actually the spec does have described ways to, if you've saturated the resources of the relay, the original vision for AMT relays was they would use Anycast, and you can still use that. So imagine you're using Anycast, so that A record could map to an Anycast address on a network operator. And if the relay runs out of resources, it can just withdraw that route so that folks won't be routed to it anymore. Yes, you couldn't, just with, as with anything, you can, send a zillion joins to relays. That's and potentially exhaust the resources. That's certainly something that implementations can block against, and that's relatively easy to protect against. In terms of the protocols, there are various ways to harden the protocols from PIM, but so the short answer is yes, and there's ways to harden things, and in terms of the implementations, and there are specs as to how best to harden it.
Thank you.
I should say, how's it? It's not dramatically different than Unicast, right? What if everybody subscribed to a live stream that was really popular, and you could have everybody joining a live stream? You could overrun the data plane, right? You could crash the server. You could kill the CDN. So in many ways, you could think of multicast as DOS protection. It is preventing data plane DOS attacks. But it certainly does introduce different vectors for control plane. But by definition, multicast is going to be much more efficient and protective of the data plane.
Okay. Yeah, but surely, but surely the three-way handshake on almost all CDNs prevents that exact thing from happening. But I'll leave it for the next question. Sorry.
There is a three-way handshake in AMT as well.
Oh, okay.
Hi, Greg Choules, ISC, formerly from a mobile operator here in the UK. I think one of the things that should be done, I don't know by whom exactly, is to try and convince the eyeball networks that they should adopt multicast internally, because then an entire network could appear to be a single client as far as the content distributors are concerned. And the reasons why the eyeball network should do this is basically, rather than their network straining to offer 2K of the big game to all of their users, their networks could operate in relative ease and offer the big game in 8K to all of their users and steal a march on the competition. So this is a very good marketing sell for why people should do this internally and make their own networks more efficient.
Yeah, and what you're actually describing is the model that Akamai has been pushing. It's kind of different than what was originally envisioned for AMT, which is basically as a last mile technology, because the thought was, the first mile had supported multicast and the last mile providers don't. So, instead of trying to convince them to turn it on, let's just tunnel over them, right? So that let's empower receivers to be able to just tunnel over any parts of the internet and access the content. But you're absolutely right. What if you're a last mile provider, and Akamai is actually doing that, and there's a thing called Dryad that Jake Holland is a big proponent of, and it does exactly what you're saying, which is imagine the last mile is multicast enabled, and you need to tunnel it back to the first mile. Because between the last mile provider and the CDN provider is unicast only. So you can use AMT as a bridge there. So that's another model that certainly works. And Jake has spoken a lot about this at IETF. I would encourage you to take a look. He's also spoken at NANOG, Packet Pushers. He's had some very promising trials and lots of great experience. So that certainly is a great model as well.
Thank you.
We've got time for one more question, I think.
Hi, Lenny. Hi, everyone. I'm Mike Hughes. I work for CDN. I'm one of those BFU guys. I've got a couple of questions. I'll also start with a pointer. I was at the Links meeting last week, and Richard Cooper from the BBC was talking about their latest experiences in UHD. The bit rates are coming down now. So you were saying 40 gig, which was 40 meg for a HD stream, very much on the top side now, and they're coming down to sub 30 meg now for a good quality UHD stream with a full color gamut. So I think when you multiply that by your Super Bowl reference, you actually lose about 150 gig per second, 150 T per second of what you're delivering. So it's quite significant. If you drop down below 30 gig with the better encodings. The other question I've got is twofold, but go ahead. Yeah, sure.
I would say, remember, that's the high water mark is what matters, right? So even if your average bandwidth is less than 30, still that's first of all, 30 is a lot. Especially when you have millions of viewers, right? And And just think of the cost. 30 times a big number is a really, really big number. Whereas, whereas if it's with multicast, that number, that marginal cost is zero. It's constant whether you have 1 million viewers or two viewers. So, but yeah, high water mark is also important to remember. It's not just necessarily average bit rate.
I just wondered if you've been keeping up with that, because that was certainly what they're seeing now as high watermark for some newer TVs. So what they said was they hadn't done any UHD for sort of 2 years. And then having come back and done the sporting events this year that were restarting, what they found was newer TVs had a much better codecs, and also the codecs had developed. So they've found the performance, even in the space of 2 years, it improved significantly and was reducing the overall bandwidth demands for UHD. Second question, and has there been any work done? You're allowed to say, hey, that's above layer 4, I can't answer that, that's fine. But has there been any work done in terms of multicast distribution with respect to implementing DRM and also implementing copyright protection such as watermarking? Because obviously if you talk to the content owners, particularly for non-free-to-air content, watermarking is really big, particularly for the high value content like sports.
Right. To answer your first question, have I been tracking bit rates? And the answer is no. I'm a network guy, so video is a black art to me. But whether it's the numbers I got were just Google, I Googled, what is the bit rate of 4K? And those are the numbers you get when, those are the first entries. So it doesn't surprise me that there might be better codecs, and they're improving and bit rates are going down. But even if it's 20 meg, it's still a big number, right? 20 meg times 15 million is 300 meg instead of 600, 300 terabits instead of 600 terabits. That's still an awful lot of terabits, right? And don't forget there's 8K, don't forget there's VR, and it just goes up from there. And audience sizes are gonna go up from there. In terms of DRM and access, the short answer is whatever you do in unicast, you can do in multicast. So UMetSat is a great example. They are encrypting their streams, and they use offline methods to distribute the decryption keys. There's no reason why that couldn't be done as well. I'm not a DRM expert, but generally I have a one-word answer for any access control and DRM question, and it is encryption. And you can do encryption with multicast just as easily as you can do it with unicast. And UMetSat is a great example of that. And they're doing multi-factor authentication. They're doing some really interesting stuff with protecting their streams, access streams.
Okay, thank you.
Sure. I appreciate everybody's time, and again, if anybody's interested, please reach out to me if you want to get involved in this. We'd love to have more folks working on it with us.
Thank you very much, Lenny. That was a fascinating and really fun talk.
Great, thank you.
Cheers. And our last speaker today is Kathy Almond from ISC. She's going to be talking about working from home, a topic I'm sure that's near and dear to all of our hearts. Kathy.
Are my slides up? Okay. Right, I'm Kathy, and it's a bit like coming to a self-help group. I'm Kathy, and I work from home, and it's been 1 year, 10 months, 3 days since I was last allowed out. So let's go and have some beers. No. I'll promise I'll keep this quick, because I'm sure everyone's aware there's not much time left. So more seriously, this is about what it's been like working from home, given that I have been working from home since 2009, and yet 18 months ago everything changed. But how different has it been between me working from home as an ordinary thing in my life and the experience of other people who have suddenly found themselves working from home unexpectedly all the time. So to set the background, ISC has a culture of working from home. We have all the tools. We've been doing it for a very long time. So it's normal for me to do that. So ISC's culture has been that we had Zoom, we have online meetings, we do interviews remotely, we have instant messaging channels for chat, one-to-one chat. We do all of the things that you would do in an office, but we do it electronically. So what has happened is that we have, during the lockdown, we have had people join us whose experience has been different from mine. They found themselves entirely working from home because they had to, and then they've joined an organisation whose culture is, hey, we all work from home. So what's different? What have we all learned from this? The meetings problem. This appears not to be entirely unique to online organisations, but it seems to have become something that's been a little bit different for organisations who suddenly find themselves with everybody at home. So let's organise more meetings because we need to talk, and the way to do it is to use these wonderful tools that we've got. So we could spend all of our time in meetings and none of our time doing work. Other issues are, so this was not a problem for me, but it would have been a problem, it would have been a thing for people who were used to working from home in their own house while everyone else went out. And now suddenly, everyone else is in the house and How do you cope with the interruptions? How do you cope with the sharing of the space? How do you cope with the childcare? How do you cope with the washing machine? How do you cope with etc.? This is an interesting one. For some people, working from home meant that they no longer had interaction with other humans at all. They didn't have anyone in their household. Some people perfectly happy with that, used to doing their interaction online and didn't mind. Other people, they were climbing up the walls. There have been not a few people who have reported actually changing careers because although they could continue to work from home, what they really wanted to do was to be with people as their career. Work-life balance is a thing as well. Particularly actually in ISC because we are a global organisation and there are things going on right around the time zone. So work from home, do I just switch off, go away? Do I want to know what's going on when I've finished my working day? Do I keep in touch? All of those are an issue. But I think this has been the hardest part to get right, the balance between what is work and what is not work. If you're at home, how do you balance, or what do you do with the extra time that you've got not doing the commute? You could do more work. You could use it to spend time productively with your family, engaging in hobbies, whatever. But that's been an interesting thing. What's been learned? This is interesting. I'm not sure. Different people have learned different things, as I mentioned before. Some people have learned that really it's not what I do, it's the fact that I do it with other people that matters to me. Other people, it has been, I really, really enjoy working from home. I don't need to live so close to my commute. I can go and live in the country. I can take up some new hobbies. I can change my work-life balance, do all of these productive things. Organisations have learned that, we don't need all of our staff in the office all of the time. We don't need to pay for this expensive office space. Our staff seem to be perfectly productive, even though we don't see them and we're not monitoring them. We have learned that you don't have to have a meeting for everything. There are other ways of communicating, and meetings and too many meetings is a bad thing, however you do it. And we've learned that the tools are out there to do those things. Do we need to travel? Don't know. Some things really do work better in person. If you're having an online meeting, have you ever tried to sing happy birthday to a team member? Who has tried this? Okay, a few hands up. It doesn't work awfully well. So there is the timing problem, as there is the interrupt problem, there is the managing who has got the speaking space issue. Some things really do work better over a bunch of beers or around a conference table. But then you've got to spend the money, you've got to spend the fuel, add to the carbon problem, etc., in order to meet up. So balance matters. I don't know what's going to happen next. Already, some people are being obliged to go back to work and they don't want to. They go back to the offices and they don't want to. They've discovered that actually they do prefer to work from home or don't want to work from home as often. There are part-time commuting type things, as in go in 2 days a week, 1 day a week. How's that going to work with train tickets and commuter prices? There are some people who are itching to get back and have changed their careers as a result. I really don't know where it's going to go, but I think there are a lot of questions that need to be asked, including the diversity problem. If you look at who are the people who typically want to work from home, they tend to be your target diversity folks. How are you going to accommodate? How are you going to balance? How are you going to be fair? How are you going to make it work? The technology's there. The next year, 2 years is probably going to be quite interesting. That's it. beers time, I think.
Thank you, Kathy. If there are any questions, we'll briefly take them, but I suspect this is the kind of thing that's going to turn into a long conversation over beers outside. Come on over.
It's Trev here. I worked from home for years, actually. I love it. Right? My daughter works for Colt, and she's in her 20s. And Colt did a survey of all the staff, hundreds of staff in London, asking who would like to come back to work in the office versus who wanted to work at home. And it was only the 20-somethings that wanted to go back and work in the office because they thrived on the social side of it. In London, they all go out for a beer afterwards, right? But most people who are not in their 20s had families and they commuted in from Brighton and God knows where, and none of them wanted to come back. Adds an interesting dimension to it, doesn't it?
It's going to be interesting balancing that, because you're going to end up with a two-tiered structure of the people who are in the office doing the wild things and the people who are remote, and balancing it so that everybody is fairly treated. Especially you've got the age generation gap thing going on as well. I don't know. That's going to be interesting.
I don't want to stop anyone going to the beer now, by the way.
I can't see anybody else rushing to ask questions, so thank you very much, Kathy, for a very topical talk.
Cheers.
Before you do all go, please do click on the Mattermost poll that is there to rate the talks. And before we go, I just want to thank again our sponsors, LoanApp and the numerous individuals, our premium patrons, Flex Optics, IPv4 Market Group and the RIPE NCC, our patrons at the promoter level, Hilco Streambank, ISC and Scrutiny, and our partners, Bogons for the video and Portfast for connectivity. The pints and packets will be held next door and the bar will be open there till I think it's 7 o'clock. Look forward to seeing you all again tomorrow and wish you all the best evening. Thank you.